All right, so now what if we add and subtract fractions that have a different denominator? So if they're different, we just can't do like we've been doing with the common denominator. So what we need to do is we need to find that common denominator. Then we need to create equivalent fractions with that denominator. Then what we can do is add or subtract after that. So least common denominator. So the LCD for a set of fractions is the smallest number divisible by each of the denominators of the given fractions. Okay, so let's think about this. So if we have 1/4 and 2/7. Well, if we're looking strictly at the denominators, what we need to do is say, well, what is 4 and what is 7? Well, 4 is 2 times 2, and 7 is just 7 times 1. So we're just going to say it's 7. Okay. Now, the least common denominator is each number to the highest power for each of them. Okay. So in this case, the LCD is going to be 2 times 7. Well, 2 times 2 is 4, times 7 is 28. So we want to get our denominator to 28. So what we can do is let's just do it over here so we can then put it right here when we're done. We can take 1/4 times what is equal to, now we want a 28 down here. Well, 4 times what is 28? Well, 4 times 7 is, but what we do in the denominator, remember, we have to do in the numerator, because 7 divided by 7 is 1. So basically, we're just multiplying by 1, but we're just creating an equivalent fraction. So now 4 times 7 is 28. 1 times 7 is 7. So 1/4 is really 7/28. So let's say 7/28. Now our other one was 2/7. So 2/7 times what is equal to, now we need a 28 in the denominator again to be common. So 7 times what is 28? Well, 7 times 4. And again, this needs to be 1, so it has to be 4/4. Now we take 2 times 4, we get 8. 4 times 7, 28. And so this is then plus 8/28. All right. Now we have that common denominator like we had in the first part of the videos here. And so now we just take 7 plus 8 all over 28. Well, 7 plus 8, that's 15 all over 28. And then that is our answer. So this one requires a little more work because we have to first find our LCD, then we have to create those equivalent fractions, and then we can either add or subtract depending on what it tells us to do. In this case, we added, and then we got our final fraction, the 15/28. All right, so to find the LCD, and this is what I kind of did on the last one, but this is kind of more in words what we're doing. So we're going to factor to prime numbers when the numbers are large. So sometimes we're going to get, big numbers in the denominator. So we're going to have to do prime factorization. So we're going to do our factoring tree. And then we're going to use each prime number the most times it is used in one factorization for either of the denominators. And then LCD is also called the least common multiple. So we've kind of seen that. And so what we're going to do is think about 8 and 12. So we need to find the LCD between 8 and 12. So what is 8? Well, 8 is 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. 12, well, that's 2 times 6, and 6 is 2 times 3. So if we need to, we could always come over here and say, well, let's break this down, 2 and 6, 2 and 3, and we have a 3, a 2, and a 2. And this was 2 and 4, that was 2 and 2, so we had 2 times 2 times 2. And so that is how we broke it down into the prime factors. Now our LCD, or LCM, depending on how you want to look at it, but it's going to be our common denominator, so I'm going to call it the LCD, is going to be, well, we have 3 2's here, we have 2 2's here, so we're going to have 2 times 2 times 2 because we want the most. And then we have 1 3 here, no 3's here, and then times 3. Okay, well, 2 times 2 times 2 is 8, times 3 is 24. So our LCD is going to be 24. And so what we can do is we can think about, okay, well, how do we get to there from what we have here? Well, a negative 3/8 times what will give us the 24? Well, 8 times 3 is 24, so 3/3. And then we can go ahead and say minus, and then we have 1 over 12 times what? Well, 12 times what is 24? 12 times 2, so that means 2 over 2. And so what we're doing here is kind of what we did over here, but we're just kind of doing it in place, as we go across the equation. So instead of coming over to the side and doing it, now we're kind of doing it right here, but it's the same thing. And so now what we can do is we can take a negative 3 times 3. Well, that gives us a negative 9 over 8 times 3 is 24. Now we have minus. Now I have 1 times 2 is 2, and then 12 times 2 is 24. And so now we've got the common denominator of 24, so we just take minus 9, and this is minus 2, or we can say plus a negative 2, okay? So we could have just wrote minus 9 minus 2, or we can say, well, we know that we just want to add the same signs here, and so minus 9 plus a negative 2. And so now 9, 10, 11, so that's going to be a minus 11 over 24, and that would be our solution to this one. Okay, so again, we're just first, doing our prime factorization, and then after that, we have to get equivalent fractions, and then after that, we can either subtract or add, depending on what it does. This one, we did subtraction. This one, we're doing adding. Okay, so it really doesn't matter, but we still have to get the LCD for both adding and subtracting. All right, so let's think about 6 and 4. Well, if we take 6, we've done it already up here. That's 2 and 3. And 4 is 2 and 2. And so what is our LCD? Well, we have 2, kind of make that a little clearer, 2 times 3 and 2 times 2. So there's 2 2's here, only 1 here, so we'll have 2 times 2. And then we have 1 3 here, no 3's here, times 3. So 2 times 2 is 4, times 3 is 12. So that's our LCD. So now what we've done is we've just done the factoring tree and gone straight to our LCD instead of kind of writing it out here. So we're kind of looking at it different ways. Different people are going to have different ways their brain works. And so we're just trying it different ways to kind of show you how that is. Now, what do we do? Well, we have to get both of those to have a LCD of 12. So let's write that. 5 over 6 times what is going to give us a 12? Because now we need a 12 here, but we're going to kind of do like we did here and write it into the problem itself. Well, 6 times 2 is 12. So if we take that, then we have to put a 2 up here as well. Plus, now we have 1 over 4. And what do we have to multiply that by? Well, 4 times 3 is 12. So what we do up here is the same thing. Now we can take 5 times 2, that's 10. 6 times 2 is 12, plus 1 times 3 is 3. 4 times 3 is 12. Well, guess what? Now we have that LCD, so now we can just add the numerator. 10 plus 3 over 12. 10 plus 3 is 13, all over our 12, okay? And again, that then would be our final answer. All right, so key again is getting that LCD. Once you get the LCD, get that equivalent fraction. Once you have equivalent fractions with the LCD, you can either add or subtract those numerators. All right, so let's continue on with these. Well, here we have a 6 and a 5. Well, 6, well, if we just kind of break it down here, again, now we're going and doing it at the base here instead of even over here. So another way to think about this. 6 is 2 and 3. 5 is 1 and 5. So our LCD is going to be 2 times 3 times 1 times 5. Well, 2 times 3 is 6, times 1 is 6, times 5 is 30. Okay. So now what we want to do is we want to make both of these fractions have the denominator of 30. So we'll have 5 over 6 times what is going to give us 30? Well, 6 times 5 we found was 30. So if we take 5 and 5, that will give us the LCD of 30. Now minus, now we have 4 over 5 times what? Well, 5 times, so guess what? 6. And then we have to have 6 here to get our 30. So now we have 5 times 5 is 25 over 30 minus 4 times 6 is 24 over 30. Now we've got the LCD of 30, so now we can take the numerator, 25, minus another numerator, which is 24, all over 30. And so 25 minus 24, that's just 1. And then we have over 30. Okay. All right, so we can do that again. Maybe we'll just keep, putting it underneath. That seemed to be pretty good instead to have to come over here. So, well, what is 7? Well, that's 1 times 7. 9, well, that's 3 times 3. So our LCD is going to be 1 times 7 times 3 times 3, which is pretty easy. And that's just going to be 9 times 7, basically, because we have 3 times 3 is 9, times 7, and then times 1 doesn't change anything. And so this is going to give us 63. Okay. So now we have to, again, get both of our fractions to equivalent fractions with that new denominator. Okay. Well, 7 times what is going to give us 63? 7 times 9, because we know basically we're going back and forth here. So that means this one's 9 times 7. And now we just put the appropriate numerators on those to make them 1. And then we can multiply and get that equivalent fraction. So 4 times 9, 36. 7 times 9, we said it was 63. Now we have 5 times 7, that's 35. And then we have 63 again. So now we've got the common denominator, so we can just write that down here. And then we take 36 minus 35. Well, 36 minus 35 is 1 over 63. Okay. Again, nothing hard. We just have to make sure we do all the steps to make it work properly along the way. First, find our LCD, then create equivalent fractions that have the same LCD, and then we subtract or add, depending on the problem, the numerators, and then we get our final fraction with that LCD. All right. What about the next one? Okay, so here we have 9, which is 3 and 3, and this is 3 and 1. Now our LCD, remember, is the one used most times in one factoring. So this one has 2 3s, this one has 1 3s, so we'll have to use 2 of them. And now we have 1 1 here, and if we remember, we multiply by 1, it doesn't change anything. So this really is our LCD. It's 9. All right, so 7 over 9. Well, guess what? That already has that LCD, so we are done with that one. It's already got the LCD, so we can leave that as is. But the second one, guess what? It doesn't have the LCD, so we have to multiply something. 3 times what will give us 9? Well, 3 times 3. So if we do it numerator and denominator, we have to do the same on top and bottom. So now that gives us 7 over 9 plus 2 times 3, which is 6. 3 times 3, 9. Now we've got the common denominator, so we can write that down here. Then we take 7 plus 6. Well, what is 7 plus 6? That's going to give us 13 all over 9. And that then is our final answer. All right, now look at this. We have something that's weird in the denominator. We have a variable and a number. So what do we do there? Well, both of those are prime, okay? And so LCD is just going to be, well, we have one of those, so X, and we have one of those, 5. So we have either X5 or more commonly rewrite the number and then the variable, so 5X. That would be our denominator. All right, so now we have 5 over x times what is going to give us. Now this one maybe what we'll do is, let's do it over on the side there. We'll rewrite this and we'll put the actual fractions after we've got them to be equivalent. So we have 5 over x, and we have to multiply by something over something. And what we want is 5x in the denominator, because we said that was our LCD, right? So that's what we want to get to. So what do we have to multiply x by to get 5x? Well, we have to multiply by 5. So guess what? We have to multiply that by 5 as well. So now we have 5 times 5 is 25. 5 times x is 5x. And so we've rewritten the first one as 25 over 5x. Now what about the next one? We have 4 over 5 times something, And now we need 5x here. So what do we have to take 5 by to get 5x? Well, we have to take it times x. And again, whatever you do in the denominator, you do in the numerator. It doesn't matter if it's a variable or if it's a constant. Now we take 4 times x and we get 4x. 5 times x, we get 5x. And so we're going to add to that 4x over 5x. Now 5x is our common denominator now, so now we just have to take 25 plus 4x. And guess what? Those are not like terms. So that's as far as we can go. Now, sometimes people like to write it 4x plus 25 over 5x. So we put the variable part first, and then we put the constant second, because then when we get to linear equations, that would be kind of more of a form like a linear equation. But either one of those is going to be the correct answer. All we're doing, when you add, you can add in any order, and so we put the variable first and then the constant second. So both of those are equivalent, okay? Or even equal in that, for that matter. All right, now we're back to just numbers. So what do we have here? Well, that's 1 and 7, and this is 2 and 4. Well, that one's done. This is 2 and 2. Okay, so the LCD is equal to what? Well, remember, when you take 1 times anything, it's just whatever you multiply it by. So we have 1 7 here and no 7's there. So that means we'll have 1 7 times. Now we've got 3 2's, no 2's. So we'll take it times 2 times 2 times 2. Okay. Well, we know 2 times 2 times 2 is 8. So 8 times 7, that's going to give us 56. So now let's go ahead and go back to what we were doing before. What do we have to multiply 7 by to get our LCD of 56? Well, we had to take 7 times 8. And whatever we take in the denominator, we also take it times the numerator. And then we have minus 5 over 8 times. Well, now 8 times what is 56? Well, guess what? That's that 7 over there. And again, numerator, denominator. Now we have 6x times 8. So what we can do is we could take 6 times 8, we get 48, times x is 48x. And that's all over 56. Minus, now we have 5 times 7. That's going to give us 35 all over 56. All right, now we have a common denominator, so we can just take and subtract, in this case, the numerators. 48x minus 35 all over 56. Now this is probably the more common way to leave it. We won't want to change it to negative 35 plus 48x. We'll leave it like this because, again, the more common way is where you have the variable and then plus or minus the next one, the constant. So we have a variable minus a constant, and so that's how we would leave it. Okay. All right, let's pause there and we'll come back in a little bit.